Across our laboratories, engineers are developing an extraordinary variety of new apparatus. Some concern guidance, others compression, resonance, field regulation, or subterranean measurement. The principles vary considerably, so I thought we would examine a few of them individually.
If the manifold is carrying 186 pounds and the secondary drop is 5, what do you make the effective delivery pressure?
181 at the injector block. Pressure is acceptable.
The real difficulty is timing. With the rotor still lagging by 2.5 degrees, the error term is 2.5 over 100 train out of phase at operating speed.
Pressure is acceptable. The problem is rotor lag. 2.5 degrees is enough to throw the system out of phase.
So the pressure is acceptable. What matters now is whether rotor drift outruns the correction rate. If it does, the phase error compounds faster than the regulator can recover.
What is the differential showing on the secondary phase register? Primary compression is holding steady, but the secondary phase lag is still 3 degrees behind the governor. If the regulator does not recover, the whole timing train will fall out of synchronization.
This is the critical point. Secondary phase lag, 3 degrees. Left unnecked, it throws the whole timing train out of synchronization. And there it is, 3 degrees off phase. Close enough to run, and close enough to ruin the whole arrangement.
The north trace is still arriving early. Did you normalize the secondary geophone against the basalt layer?
I did, with phase delay at 0.7 and attenuation at 1/2 feet. If the harmonic rises above 6.2 cycles, we are no longer reading bedrock, we are reading the void beyond it.
Then the western seam is refracting the signal and recommit a void in late.
Exactly.
This is shaft 7. Down here, we can compare those seismic readings with what the rock is actually telling us.
Taken together, the shaft 7 traces indicate a void beyond bedrock. With that established, we can move on to the next section.
Doctor, what is the reading on the secondary register?
The secondary register is stable at 112, but the modulation remains uneven. Without phase correction, the compression sequence will drift out of calibration.
They were right, the secondary register is steady enough, but the modulation still wanders. That is why the regulator must be corrected before the sequence drifts. So the reading tells only half the story. The waveform shows whether the compression cycle is actually behaving.
When you separated the upper housing, did the third retaining ring come free before the induction sleeve, or did you have to relieve the pressure from the inner collar first? Neither. The retaining ring is only nominally structural. The real load is carried through the nested compression racement sleeves. The collet first, they'll bias to the secondary lattice, and the whole calibration geometry becomes meaningless.
The retaining ring only locates the assembly. The real load rides in the compression race, so the collar must quarter turn, counter bias, then extract under reduced tension. This is the records and recovery laboratory, where dismantled instruments are examined, identified, and returned to useful record.
So it just makes the red wheel go round faster?
Not quite. At 120 cycles, induced flux scales approximately with n squared over pi r, while phase attenuation follows the inverse square. The wheel is only the mechanical residue of the field differential.
So yes, the red wheel goes faster, but only because more of the field imbalance is being converted into rotation.
Increasingly, it is electronics that gives modern communication its speed, range, and precision.
Vacuum tubes, carrier circuits, relays, and teleprinters move more traffic over existing lines, while radio carries signals beyond the reach of wire.
What is the thermal differential across the primary condenser?
The primary condenser is holding a 12-degree differential, but the return impedance remains too high.
The outer resolver bank is only the first reduction stage. True correction begins in the differential synchro array, where heading error is summed against gyro precession and translated through the servo integrator.
Induction remains stable to 2200 cycles, provided the governor holds synchronization and the condenser bank does not exceed its thermal ceiling. Secondary drop is 5. Effective pressure? 181. Acceptable, but with 2-degree rotor lag, the compression train won't stay in phase.
Every gauge, circuit, and mechanism represents another attempt to bring order to complexity, and another small advance in what engineering can accomplish. From compression and seismic measurement to recovered instruments and radio, each machine reflects the same ambition: greater precision, greater understanding, and greater control.
Your paperwork states that the device produces no hazardous emissions.
None that we can measure.
That is not quite the same statement.
No, sir. It is considerably more accurate.